Welcome to Season 6 of the Prosthetics and Orthotics podcast. We are absolutely thrilled to have you on board. We're talking to experts who know their stuff, the patients who've experienced these technologies firsthand, the vendors who provided the tools, and the thought leaders shaping the future. Together, we will uncover the ways to make the lives of those relying on these incredible technologies even better. We hope these discussions are going to be the highlight of your day.
Hi, everyone. My name is Joris Peels, and this is another episode of the Prosthetics and Orthotics podcast with Brent Wright. How are you doing, Brent?
Hey, Joris. Doing well. You know, it's been interesting lately. We have had a local group wanting to do fracture braces for patients, and we've been doing quick turn multi-jet fusion fracture braces, so literally printing overnight, finishing, and delivering the next day. I never thought that I would do that. I know you and I have talked about upper extremity orthoses and the cast thing and all that. I can't say that it's like a massive moneymaker, but what it does do is it trains us to not only be efficient with our design, but it also is one of those things that's out in the public eye. Right. So some of these things, you know, patients, you know, with social media the way it is now, you know, everybody knows that somebody's aunt, uncle, broken arm or whatever. Oh, take a look at this thing. And it kind of puts you top of mind, not only on the social media side of things, but then also with some of the doctors that are treating these.
And what's the advantage here? Apart from like it's less itchy because it's better to get to the itchy bits or what?
Yeah, so I think that's definitely one of the advantages. The other advantage is like showering and that sort of thing. Like you don't have to take it off. Like you can get it wet, you can go swimming, you can go do all the things that you weren't normally able to do. The other thing that's been interesting through all of this is there are people that have essentially non-healing or long healing fractures. And this it's a perfect case for that. Like yesterday, without getting too in the weeds, we had a lady and she's had a non-healing fracture for like going on 3 months, but it needs to be immobilized, and you can't be wearing a cast for that long, and it not be stinking. And she's super active, still working, very very intense job, sweating, all that stuff, and so. Like I said, it's not, I'm not going to become a millionaire doing this thing, but it's definitely been interesting. And here's the other part of this that we learned. A lot of people ask me, hey, well, how do I get involved with some of that? There's no way to contract manufacture those devices. You will literally lose money. The only way is to have a machine in-house. And a lot of times it doesn't make sense. Unless you do FDM, which is totally possible. So, but that's getting in the weeds. But anyway, I thought that would be an interesting kind of segue because I kind of said I would never do that kind of stuff.
We're both intensely skeptical about this because the efficacy of it and the time and all that kind of stuff. And you wait longer, and it's actually kind of like you actually inconvenience the patient. It's more expensive, But for the longer term stuff and for fragile bone people, for people that have, really post-operative healing that's very difficult or they need to be immobilized in a particular way, there I'm a huge fan of this, right? I'm just not entirely sure we're there yet on everyone with a broken arm, But if, long-term fixation for really complicated stuff, love it. Love this kind of stuff. And the example you mentioned is a kind of in-between example that is actually really, really good. And that could be really interesting as well.
It's a tool in the toolbox. I think that's what it comes down to for us, and it's the one tool that you never think you're going to use, and you kind of put it off to the side and hope it gets dusty and you never have to use it. But, we're using it. And what's nice is that we can use it and we have the ability to do it. So I think that's what's interesting about this whole digital side of things is, the answer may not be digital everything. But you know what the answer is education and knowing how to use it and when to use it and why to use it. So it's in your toolbox. So when it comes about, you say, you're not left hanging well, I'm not able to do that because that's not what I do. Put it in your toolbox and figure it out.
Okay. All right. So who's our sponsor for this podcast, Brent?
Yeah, well, we actually have two sponsors. The first sponsor is the Indiana Institute for Prosthetics and Matthew Habecker. And what I really love about this story is Matthew's, I guess you would say a fan of the show. And he said, Brent, I really just love what you guys are doing and want to sponsor you. And so he's done just that. So the Indiana Institute for Prosthetics, if you're an amputee or looking for some place to go in Indiana, and has come up with some really creative solutions. So really appreciate him for sponsoring and sharing the love for the Orthotics and Prosthetics podcast. So I think that's pretty neat.
Yeah, me too, man. That's awesome, dude. And so who's our second sponsor for today, Brent?
Our second sponsor today is called OneSource, and it's under the umbrella from Bionic Prosthetics and Orthotics. We had Tony on, and he shared a little bit about the heart behind OneSource and really just the bottlenecks that we have as a clinic when it comes to having all the notes and codes in place to get paid for the prosthetic and orthotic devices. And then on top of that, they also provide some digital services, as like 3D printing your check sockets, and a place to save your files, which we've talked about quite a bit. And on top of that, you get pretty hefty discounts using them for kind of a one-stop shop for all the components that go into a prosthesis. So pretty neat, pretty visionary too. And I know we've talked about, hey, these solutions should exist.
That's a good idea. Okay, cool. Who's on the show today, Brent?
Yeah, well, sorry, Henrik. We got into the weeds big time on this one. So I'm really excited about having Henrik Lundell on from Prototal. And Henrik and I got to know each other a little bit through an interesting way. So we've had Katie Leatherwood on the show from Latvia. She's a prosthetist in Latvia, and she sees a lot of patients that are not only Ukrainian refugees, but sometimes Ukrainian soldiers. And we were trying to figure out, how do we get multi-jet fusion sockets to her in Latvia? And really shipping from the US doesn't make a lot of sense because of all the EU customs and all that kind of craziness and packages getting lost. And we never even tried that. We just knew that that's not a good option. So I reached out to Henrik, and we ended up talking, and he heard kind of the heart behind the whole thing. And they stepped up to the plate, and they've done an amazing job with quick turnaround times for Katie. A lot of times she's getting her prostheses within the week. So we're actually doing this whole centralized design, decentralized production worldwide. So I do a lot of the design for Katie. I send it over to Henrik. Henrik gets it, prints it. He ships it over the pond to Katie. And literally within a week, she can be fitting that patient with a multi-jet fusion socket. And I think that's really cool. So I'm excited to have him on just to talk a little bit about, contract manufacturing, the importance of it. And we can dive into the weeds from there.
Awesome, dude. Really, really excited. So, Henrik, welcome to the show.
Great. Thanks, guys. It's a pleasure to be here. Really honored to take part in this recording and see what I can contribute with. And I hope there will be an interesting discussion for sure.
Perfect. We do too. So first off, how did you get involved with orthotics and prosthetics?
Yeah, I think I need to step back a bit before that. When I started entering the 3D world, which was quite a lot of years now, I started in this company already the year 2000 with the ambition originally to be an architect and trying to implement 3D CAD into architectural models and so on. And then I stumbled into this Prototal company that I'm representing since then. And with the background I have in my family, who are doctors, my parents and my brothers and sisters are in that field as well of work. We always had an interest for this kind of medical applications, and that has always been a great driver for us in the family. And helping people for a better life quality is really inspiring and satisfying. And then I started to implement that into the company and trying to offer these kind of services to different hospitals and clinics as yourself.
Okay. And then, and so from a 3D printing point of view, you guys are you like are you a 3D printing and rapid manufacturing firm that does like prosthetics? Is it a small part of your business, or how do we see it?
It is a very quickly and rapidly growing business, part of our business. We are hosting closer to 90 professional 3D printing systems or additive manufacturing systems in our group. So we have quite a big fleet of machines. Medical applications is one of the top segments or sectors that we are working with. And we do have a couple of the sites where we are offering these kind of services throughout Europe. We have representation in 6 countries, and a couple of them have medical certificates, and we are running quite a lot of both contract manufacturing and individual models like rapid prototyping sort of thing. So that's a mix of it, but it's constantly growing, and it's super exciting, I should say.
Okay. And then since, of course, 2000, a lot has changed in the 3D printing business, right? So, what's changed from your point of view? Like, just from like, I don't know, we can start with the list of like, first of all, like in the software front, what's changed over the 2 decades?
I mean, it's a completely new world, I should say. In the beginning, we just received CT scans, bone fragments, and we extracted those from different softwares to get the bones out and trying to print those to the scanners that we have today and the flexibility. So there's an enormous change in how that has been developed. But also I should say that the biggest thing that has changed is the way the users see this technology now and the flexibility that it brings to the market and the more or less impossible things that we can create with this technology. And the knowledge about that is amazing that, people like you and Brent and others has discovered and can really see the benefits from. And that is a major milestone, I should say.
Okay, that's good. And then, and just a really practical question. If I would want to outsource, some kind of thing, like if I want to outsource a 3D scan that I want to make a part of, or I want a CT that I want to make a part of, what are some tips? What are some things to make sure that working with the outsourcing partner is going to be successful the first time I do that?
You need to secure the accuracy of the thing that is creating the 3D CAD file. You need to have some competence about that, of course. But it's so easy to learn, and it's more or less self-learning. A lot of clinics have started up, and we are serving them with some initial tips and tricks, and then they just go by themselves and defining how the implant or whatever it should be, orthosis or something like that, and the limitations of that, and then they just go with the flow. And I mean, the technology can produce anything, so there's more or less no limitations in it.
Okay. And then, so in terms of the machines, what really has changed in terms of machines? Because like in the 20 years ago, there was like SLA and maybe one or maybe 1 or 2 sintering machines, a DTM machine or something like that. Like there was that landscape has changed significantly as well, right?
Absolutely. I mean, the company that Prototal is sprung from is Electrolux, and we actually had the first SLA machine that came to Europe, 1988. And if you had a bad morning and you looked angry at the part coming out of the machine, it cracked. So the usage of those machines were not really up to speed with what we can see today. And I mean, we are producing functional parts with high speed, with good accuracy, and really long life functional parts, which is amazing in that comparison. Absolutely.
And Electrolux actually, like, maybe a little bit less known to American audience, large consumer goods, electronics conglomerate that was actually really instrumental in getting SLA more widely known, and then later on also developing the metal printing parts and industrializing the sintering-based technologies as well, right?
Yeah, absolutely. So they had big centers also in another Nordic country, Finland, where they developed the powders for metal printing as well. So they were early adopters, and they drove some of the developments in that field. Absolutely. So they were pioneers, you could say.
It's insane about the role that Electrolux took out in developing 3D printing, like not only in Europe, but worldwide, especially on the metal and the sintering front and some of the polymer stuff is insane, really. If you think about it, it's just, but there was a lot of other, large conglomerates and electronics companies at the time. And they didn't take such a pioneering role. So I think that's actually really wonderful. So that's actually kind of cool that you guys were part of that, because that was really kind of the ground floor as far as Europe is concerned. You guys and maybe Charlie and maybe Fried over at Materialize stuff. There was only there's like 3 or 4 people at the time doing stuff.
Yeah, exactly like that. I mean, the comparison with the older technologies, and I mean, that is also one observation, I should say, that old machinery still functional actually, but and of course with some updates, but trying to cope with the speed and the demands and the requests from the market, and especially within the medical application field, we need to be in the front line in terms of new technology and to be able to serve with a cost model that is working for these kind of parts and also the speed required, especially when we're talking about the models that we are producing for Katie and her team together with Brent's designs. Time is of great importance, and we need to be flexible and quick. And that is also one of the big changes in terms of the newer machinery.
Yeah, exactly. And if you look at the combination of material, software, machine, you kind of like pointed to it. Like you used to have parts that cracked. There was a lot of UV degradation. There was a lot of parts that would just not be able to stand up to normal heat and stuff. And now we've got much more kind of like life ready, kind of like end use kind of parts. And have you really seen that grow in your business as well, going from pure prototyping to many more end use parts?
Absolutely, and that is a big thing for us now, and one of more or less my daily work as we speak is to really find production volumes and teach people how to use AM as a way of as a production method. And I would say that easily over 50% of the models we are producing today are end user applications, and less than 50% nowadays is single prototypes and so on. So it's been a game-changing effect in that sense as well.
And if we're looking at end-use parts, what are you seeing, or what kind of industries or applications are you seeing these end-use parts in?
It's more or less all over, all kind of sectors. Medical has been one driver, I would say. Quite a lot of surgical guides. That is quite big volumes for us. We do quite a lot of industrial applications. There are some aerospace, and since Sweden is quite connected to some of the bigger automotive producers like Volvo and stuff like that, that has also been a big fraction of our production volumes to produce automotive parts.
And what are you seeing as really like what's holding us back? Is it really the cost of the system, or is the materials too expensive, or is it just too much manual labor? Kind of a combination of those things, or
the biggest threshold was before that the part coming out of the machinery was not really looking like a machined part or a perfect part in terms of surfaces and so on. That threshold has been removed a bit, especially with the post-processing equipment that is connected to this kind of machinery. So the big step now is teaching people and getting the mindset of design for additive. And that's something, mantra, whatever we should call it, that we are trying to really push out to the market to get people to understand that if you create a smart design, additive manufacturing is really something that could be very helpful and cost effective if you do it right. So design for additive is probably the biggest hurdle at this point.
So give me like a design for additive 101. I mean, what's the let's say imagine I'm a regular designer, I have some experience in CAD. What do I really need to like switch in my thinking in order to start to be able to design for additive?
I mean, you need to remove all the old regulations in terms of implementing draft angles, getting undercuts and stuff like that. That is not an issue anymore. And you need to see beyond that, I should say, to really understand that with additive, you can produce more or less everything that is possible to produce. You don't have any limitations, and you need to trust the technology and the strength that the parts provide, especially with the new materials and the newer machinery. And so there, get rid of all the draft angles and the way of looking how to produce a polymer or a metal part, for that sense, even though we are focusing on polymers in our business. But a lot of designers and CAD workers, they are so limited and trained the old way in how they should design a product. And that's something that is a big limitation when getting them over to the AM side.
I think that's a pretty interesting point. And, Joris and I talk about education quite a bit, and this idea of design for manufacturing. In your experience, let's just say Sweden and beyond, are you seeing a pivot of some of the schools and the way the people are designing, or is it more like a on-the-job training sort of thing with companies like an Electrolux or something like that are already pushed into additive manufacturing, and they're bringing in, classically trained, for lack of a better term, designers and training them in the way of DFAM for them?
I mean, I put quite a lot of time and effort into getting these educational seats, like the universities and things like that, to adopt this. And I'm sitting in the board of a couple of these educations or at different universities throughout Sweden, and trying to make them understand. And we have quite a good success, at least in the southern parts of Sweden so far. So there is actually 5 different university-connected educations that has now 10-12 weeks of DFAM courses. There are 3D printing specialists that get these trainings, and during a 2-year period and so on. And I put quite a lot of effort into getting them to understand this, and that has given some fruit so far. And it's really up there now and being discussed. And so that's something that we put a lot of time into.
Okay, and that engagement, I like that you're doing that. That engagement sounds like a really good idea, business-wise, but also just to help the industry. And I think, do you have any tips for people trying to do that themselves? I mean, how do you convince the university? Just slowly, you have to prove it to them? Or is it just a promise of the industry, or are you going to tell them their students are going to have a better chance of getting a job? What's the levers, really, with these universities to get them to do this?
I mean, it's been during the last couple of years with some economical crisis back and forth. There has been a lot of discussions, and since we are in the size that we are, and we have these kind of needs for future employments, I've been able, through that and with that muscle force that brings, to get some impact and being listened to. And for that reason, they took it in, and now they see that out of those 25, 30 students that comes out every year, all of them get employments within this kind of field of work, which is a big factor of success, and that gives them the possibilities to search and get fundings for keeping those classes alive.
That's good, and I like that. It sounds like a really big success. But also, when designing a program, like you're talking in like a number of weeks, what do you think is the right amount of time to devote for like a DFAM education to give an engineer like a good background?
If you have a CAD design background from the beginning, and you can find your way in your CAD software, the basics of making a design, then a couple of weeks with the basics, then you're good to go, I would say. And then it's just training and practices.
Okay. All right. That sounds solid. And so you guys, we all know that Brent is like the ultimate MJF fanboy. So we could talk about MJF if you want to, but we get back to it when we talk about, I think, the prosthetics you guys are doing together with Katie and stuff. But let's talk a little bit about some of the other technologies, because we haven't really talked about them that much. So I think that would be good to now look at some other stuff. We discussed in the podcast FDM often, because it comes up and people just doing it themselves. And a lot of people start with the FDM. Well, there's desktop machines in the market. Then we also end up always discussing MJF because of Brent always. So you guys have other kind of materials as well that maybe are a little less known. I think the one is the one that's, well, a little bit different. You guys run both. So, there's selective laser sintering, also called powder bed fusion, which is, well, essentially very, very similar to MGF, but laser only, if you will.
No.
Is there, do you see, you run both processes in-house? Do you see a lot of differences? Is there reasons for you to consider one technology over the other one, or do you see advantages to SLS?
I mean, looking at the SLS and the existing machine park available today, there are some bigger platform printers which fit some kind of purpose in terms of special design and special sized products in terms of production volumes, like a SLS P7 series that could fit closer to 3 full buckets of MGF, and that gives some kind of efficiency in production, tolerances, surfaces, air tightness, water tightness. There are some small differences between them, but in many cases, with the kind of applications that we have in our customer base, it's not so relevant for them unless we need some kind of special post-treatment and there are some special demands on the products, because it's a bit more isotropic with the MGF, and which makes those parts a bit more airtight and fluid tight. And you can do some really nice things with those. But there are some good examples also with the SLS. So it's it's the $1 million question, more or less. What is
I know.
So we are using both of them because a lot of customers are used to one or the other, and for that reason we keep investing in both technologies. We fill them with slightly different kind of parts, I should say, but quite.
Well, that's interesting. Is it just the size, or is it? What are some of the other differences then you see there?
I mean, printing a larger part with good quality without having the need of cutting it into several pieces and then glue them together, that will of course give a stronger and more rigid part. And for that, as soon as we have bigger parts, we tend to produce them in laser sintering with SLS technology, and especially in the P7 systems. When going into production volumes with smaller parts, the MDF machines that we know runs for a certain amount of hours, no matter what kind of volume you put into it. So there's benefits on that side. So, but larger parts, of course, that goes more frequent into SLS.
Okay, that's cool. And then also, there's a couple of materials I think I really that are quite interesting in SLS as well. We've got the kind of like the main edge of the market to everyone's materials of PA22, it's a polyamide 12, right? Which is also really, really suited to a lot of the medical applications. It's biocompatible and stuff like that, so it's really nice. And there's PA11, which we also have an analogous material at MGF. But there's some other ones as well, right? There's more fire retardant materials. There's there's other there's polypropylene as well, which we also have in MGF, right? But there's also there's a little bit of GF, that's like loaded materials like that.
Yeah.
So there's a little bit broader materials. Well, I think the GF materials is something that could be quite interesting for the people listening.
Yeah, I think that, I mean, a bit stiffer and more rigid materials, especially when you put the load that some of the parts that you are bringing to the market with your designs should last for some good loads, and for that reason the GF materials or the GB materials for MGF technology is could be a very good alternative. But you have also the other materials with the flex and the elongation and break and technical aspects like that. So you really need to know what kind of load and how will this part be used. And then we as an expert could guide you to choose correct material, correct production method for each and every occasion, because that is one of the big tricks to really find the suitable product from the best technology available.
What do you give up when you go to a glass bead or a glass filled, either a PA11 or PA12? So what's the trade-off, right? Yes, you go stiffer, but do you lose some of that elongation and impact resistance?
Yeah.
Or what?
Exactly.
What is the trade-off?
Yeah, it's exactly as you say. It's the elongation and the impact that is getting weaker, but it's stronger in X and Y and Z as a stiff material, and that could hold bigger loads without cracking, but you give up some of the elongation and the impact strength.
So would you say, like for orthotics and prosthetics, when would it make sense and when would it not make sense specifically for that?
I think that you need to look both into the patient that should wear this kind of prosthesis and stuff like that. And in many successful cases that we have provided, there's often a combination of different materials. Like in your designs, there is a combination of softer materials together with some more rigid materials. And if you're closer down to the foot, you might need some flexible things. Or you closer to the knee or higher up, you might need some more rigid things with glass beads or glass fiber reinforcements. Neck and shoulders and arms and so on, maybe standard nylon PA12. So this, you need to try and test, but I would say as an overall guide, I would probably be using, depending on the need for the patient, and that should always come in the first room, I guess.
Yeah. Well, and I'm also curious, when, in Europe, PA11 in the orthotic and prosthetic realm is used almost exclusively as far as I've seen. Whereas in the US, the PA12, a lot of people design around the PA12. What are you seeing there, and what are some considerations when talking PA11 versus PA12?
I mean, one of the biggest driver with PA11, as we see it now as an industrial partner or a contract manufacturer, is of course the need of bringing the thought of sustainability into this industry as well. And PA11 is the smarter choice in that sense, because it's made from castor beans, from the instead of petroleum-based material, and that is a big aspect, and something that I wouldn't be surprised if we see some regulations in 10 years or something like that, that petroleum-based materials for one-offs and things that might be thrown away after a few months or a few years of usage. There needs to be some kind of thought about the sustainable aspect as well. So PA11 is a very good material from that aspect. The flexibility and the elongations, they are the PA11 is behaving better in that sense. So for that reason, PA11 will be in a 5-10 years period will replace a big amount of the PA12. That's my personal thoughts about it.
I think also what's really important is if we get into the end customer part, especially I've noticed that startups, for example, they love it. They love that claim. It's like it's made out of castor bean. They love that, be able to say, you know what, we're making this part. It's only made of this material. It's few materials, only made in one location, made close to the consumer. And by the way, it's made from castor beans and from Archimet, the Marcos PA11. So I think that's an absolutely fantastic thing if you're moving, specifically when you're moving into end-use parts, and then people could put it on the product, on the website, and then that kind of thing will be even more enhanced.
Yeah. And I mean, that's part of our strategy, since we are now in 6 different countries in Europe, and we are continuously growing and finding new places to put our foot. And that is to serve the market with a close by production and shipments that should not be carried by long distance trucks and stuff like that. So that's also a very big, important factor.
I think that's really good. And well, Brent, you wanted to ask something, or is that?
Well, so I do think, and yours, you may be able to chime in on this too. So at least the people that I know that run contract manufacturers, they're like, yes, the PA11 is amazing. It is sustainable with the castor beans and that sort of thing. It is more expensive. Like we see roughly about 30% more expensive than the PA12. But then they also say, well, listen, what's interesting is the PA11 gets you more resolution, which means the particle size is smaller, but it also gets into every little part of your machine, whether it be SLS or MJF, leading to issues further down the road. Consumables and just general wear and tear happens quicker. And so I was just wondering what your thoughts or what you've seen on that front. On PA11's an amazing material, but there is a little bit of a trick to run it as well to make sure that you keep everything in tip-top shape.
Yeah, I totally agree with you, Brent. I would start with saying that if the consumption of PA11 was closer to the consumption we have today in the industry of PA12, the price would not be an issue. So that is more or less related to the low volumes that is used, and the production cost will be more since it's not produced in that scale. So if more people would change into PA11, the price it would not be an issue for the future. So that should be easy to take care of as long as people would be more careful about the sustainability and really see the benefits. In terms of the technical aspects, you need to have a very controlled environment when you're printing in general, and specifically with PA11. You need to be more careful, you need to be more trained and have good knowledge about it. And you need to have your quality routines, cleaning of the machines, being accurate, not only with the printers, but also the post-processing and everything surrounding the production of an additive part. So it's a bit more challenging, absolutely. But if you have control over your production, it's not a big thing, I should say, but you need to be a bit more careful.
Yeah, I think that's a really good point. I think that's a super solid point. I mean, I think we'll get used to it. I mean, if this is the new normal, let's say, then this is the new normal as well. I think that's very interesting. And then one thing I wanted to talk about, another thing, material that's super not green at the moment is things like PEEK and PEC and stuff, right? They're much more difficult to print. We have really, really low recyclability on the powders. It's terrible, actually, from an environmental point, and the economics of it are terrible as well, some of these materials as well. But it's a really ultra-high strength material. We could use a lot less part. Are you guys thinking about using that, or is that just like, are you saying that's just aerospace only? That's going to take a while to trickle down to real consumer goods and things.
I mean, when you run a business like we do, you need to look where are the businesses, where are the needs, and for materials like that, the PEEK, the PEC, the high temp material, and really special edition materials, it's not so frequently asked from the customer base we are serving, and for that reason, we are not running that with the powder bed systems that we have, but we run them in FDM systems like the Robos, where we have this carbon PEEK and different applications that is more into replacing metal printing or metal parts, really tough, exclusive materials with really good properties. But as you say, aerospace and stuff like that, that is maybe oil and gas industry as well, but not so big or many requests from that, which makes among our 90 plus systems in additive, we are not running only in a couple of them that kind of materials.
Yeah, it's still very exotic, but I love it for prosthetics because we can get a lot of the strength in sockets and things that we can't get from these other processing materials. But okay, so another thing we don't actually really talk about a lot is SLA, the original technology, essentially vat polymerization, which laser in a vat. If you know, you probably know analogous technology from the Forum Labs, a similar kind of desktop printer. You guys run rather larger, iPro SLA kind of systems from 3D Systems and stuff like that, right? So SLA, how do you see it for prosthetics? Because for covers and stuff, I think it's fantastic. For small parts, I think it's great. Do you think it goes beyond that, or?
Yeah, I mean, there are many nice applications, especially within the medical fields, like surgical guides for temporary usage. If you go to the oral side of the world where we're replacing teeth and tooth and stuff like that, that could be, and we have produced several thousands and thousands of those kind of parts with SLA, because the accuracy was much, much better back 5-10 years ago. SLA was really dominant in terms of accuracy and surfaces and so on. And so for that reason, SLA was the easy choice of what to choose the production method for those kind of applications. I mean, SLA has also developed in terms of different materials with different properties and getting more stable, not so, I mean, still dangerous materials, and you need to be very cautious when you treat it, when it's in fluids. But as long as it's been hit by UV lights and cured afterwards, it's quite nice to handle. And so SLA absolutely have their spot in the world in this field of industry.
And how do you see the because, like, if we look at the kind of contract manufacturing business, it's kind of weird because on the one hand, I think the general belief is that a lot of it is going to get commoditized. And the other belief is that a lot of it is going to get, well, a lot of clients are going to 3D print as well. But we also see companies like Syntavia in the US and stuff, people with the highest quality kind of management systems, the highest kind of, quality machines and processes. We see them doing very well in end-use parts for example, heat sinks for aerospace and all this kind of stuff. So we see these guys actually do disproportionately well because they're only one of very few companies that can really talk about, the really large scale kind of, they talk to, they can talk to Boeing and the satellite vendors and all this kind of stuff. And they seem to be have a disproportionately large opportunity. Meanwhile, there's other companies buying up service bureaus right, left, and center, let's say. What do you see yourselves as a role? Do you think, you're going to be one of the bigger ones? Is that how you're going to survive, or the quality player, or what do you hope to do?
I think you need to see that in a combination, because you will never succeed as a contract manufacturer without keeping the high level of quality, because the demands on a ongoing production volume, comparing to injection molding, for example, since we also have injection molding in our portfolio with over 130 injection molding machines in the group, and the demands on production volumes is easily transferred into injection mold to additive. But if you don't know what those demands and requests are, you are in big trouble. So you really need to be accurate with how you present and how your QA department is working with this kind of contract manufacturing within additive, because it's the demands and the control functions that you need to secure that you are on the safe side with, and you have the repeatability and so on. It's crucial for you as a company, but also for the trustworthiness of the products coming out from additive.
Okay, I think that's a really, really good kind of way to say, hey, it's more than just focusing on just one area. Talk to us a little bit about this project you guys are doing for Ukraine. How did you get involved with it, and then what are you guys doing at the moment?
Yeah, as Brent said in the beginning of the talk we have today, is that we were contacted or connected through one of the mutual friend in the industry, and one thing led to another, and Brent started to challenge me with some of his really nice designs and pushing some boundaries in terms of lead time and complexity, and I think we, as you said, stood up on the plate and have been trying to deliver and in a controlled manner to supply for a very good cause for this Katie Leatherwood, with the great work that she's doing and supporting those people that are really in a need, which is very inspiring for us as a company, and just trying to help out. I wish we could do more, and I wish that we can do even more models, of course. So on the other hand, it's a pity that those models are needed for the Ukrainian soldiers, but that is maybe a separate discussion.
Well, and what's neat is, and Katie's kind of just taking the bull by the horns as far as that I think she might have submitted it to you yesterday, but she did that design from start to finish. As we've been helping her kind of get up to speed on some of the design and design constraints. And so if you don't have a file, you're going to be getting one soon, but she is well on her way to becoming very independent with the multi-jet fusion design. So I see her definitely using you guys more. But Joris, what's interesting about, and Henrik kind of alluded to it, in the United States, I have never had somebody, contract manufacturer, successfully print. It's a very specific type of prosthesis that's not only a thin wall, but there's multiple components that go into the bottom of the prosthesis. So there's not only threads, there's a slide, and the tolerances just have to be perfect. And I've tried a bunch of contract manufacturers in the US. And so I asked Henrik, could he do it? Because I've never had somebody do it before. And he goes, well, we'll try it. And I was like, oh boy, I don't know about that. And they did it. And sure enough, man, it was right on the money. So I just thought that was really great that, you send this high tolerance part that's very difficult to print to a company. I've never even seen the product before, but they put it in Katie's hands and everything assembled perfectly. And that's what you want in a contract manufacturer. And, hats off to them for doing all that, in an excellent way. And so I think that's really neat.
Yeah, thanks for that, Brent. It was a challenge, but and that comes back to the previous discussion that if you're aiming to be one of those fighting in the contract manufacturing arena, you need to have full control over your production processes and so on, and everything from controlled air and ventilation and humidity in your production facilities and so on. And that is the one thing that makes this possible. And also, of course, the control functions afterwards. In this case, it actually was on the first print, so we didn't have to redo it. So we just nailed it, luckily for us, and the nice words from you, Brent. But it's a lot of efforts behind it to secure that you can deliver on that quality level.
Okay, that's super cool. And yeah, just so if somebody's the prosthetics people from Europe are watching, you guys are you active all across Europe or certain countries, or?
We offer our services all over Europe and for sure in the States as well, even though there are, the transports and so on. So we have no representation in the States at this point, I should say, because we are constantly growing and we have ambitions with the group. But so far we are represented throughout Europe, from the Nordics down to the south of Europe, where Italy is our foremost south facility. But Austria and UK and the Nordics is among those countries with 11 different sites in Europe. So we have a quite good reach to supply, especially in Europe, with quick deliveries and so on.
Okay, that's super cool. I hope somebody is listening and maybe has a chance to try you guys out. Henrik, thank you so much for your time today.
It was a pleasure, guys. I'm glad that you had me on your show. Really appreciate that.
Anytime. And Brent, thank you for being here as well.
This was great. Thank you, Henrik, for being here and just sharing your knowledge about contract manufacturing, and then diving into some of the materials and some of the stuff for O&P. I really appreciate that.
And this was another episode of the Prosthetics and Orthotics podcast with Brent Wright and Joris Peels. Have a great day.